Good morning, friends. I hope everyone is doing well. I request everyone to watch my videos in a sequence for better understanding. If you really like my teaching and my efforts, please press the like button, share the videos with your friends, subscribe to my channel, and also press the bell button to get the regular updates. In the last video, I have discussed how to simplify a Boolean expression with a series of steps. Am I right or wrong? Then I even discussed about one example for better understanding. In this video, I want to discuss another example of how to simplify a Boolean expression using the K-maps. So I request everyone to watch the complete video for better understanding. So they have given a function which consists of four Boolean variables A, B, C and D, and they have given a Boolean expression which is in the form of sum of products. Am I right? So we have how many min terms are there? Totally we have 10 min terms are there. Okay, so now what I have to do? First I need to find the number of cells in the K-map. If you have 4 Boolean variables, you will have 16 cells are possible. Why? If you have n Boolean variables, the K-map will have 2 power n cells. In this given example, you have 4 Boolean variables. So totally 16 cells are possible. So first we will find those 16 cells. Okay, let me write all those things. Now we can take the AB here, CD here, or we can interchange also. Okay, AB can be kept here, CD can be kept here. It is your convenience. 0 0 0 1 1 1 1 0. This is very important, and this is 0 0 0 1 1 1 1 0. Are you able to understand it or not? Now let me keep the min terms in the K map. Now how to keep it? The first min term is 0. So 0 is nothing but 0 0 0. Why I have taken 4 bits? Because you have 4 Boolean variables. Now 0 0 0 0. Where I should keep it? First we need to see the AB, then CD. So 0 0 0 0, which is this location. Are you able to understand? Next 1. 1 if you convert into binary number 0 0 1. What is the place? 0 0 0 1. So this is the location. Now 2. 0 0 1 0. So 0 0 1 0. This is the location. Now 5. 0 1 0 1. Will you agree with me or not? So 0 1 0 1. So this is the position. Then you have a 7. 7 is what? 0 triple 1. Okay. So 0 1 then double 1. This is the location. Then 8. 8 can be represented as 1 0 0 0. So 1 0 0 0. This is the location. Then 9. 1 0 0 1. So 1 0 0 1. This is the location. 10. 1 0 1 0. Are you able to follow it or not? Even you can pause the video and you can fill all the min terms in the K map. 1 0 1 0. 1 0 1 0. So this is the position. Now 13. 13 is what? 8 plus 4 is 12 and 1 13. Okay, because this is 2 power 0, 2 power 1, 2 power 2, 2 power 3. So 8 plus 4 plus 1, which is 13. So double 1. Okay, 0 1. This is the position. 15 is what? 4 ones. Okay, double 1 double 1. So this is the 10 ones should be there because 10 min terms are there because each term should be covered in the K maps. Okay, 1 1 2 3 7 3 10 are there. Okay, so the step 1 is completed because all the min terms should be covered in the K map. Okay, now we will see what are the steps. Other steps we have to do. We have to group the adjacent cells as large as possible. Now if you see that I can group these four, whether they are adjacent or not. Will you agree with me? Yes, they are adjacent. And can I join these two, or can I group this one? Whether they are adjacent or not? Yes, they are adjacent. How so? Because if you see that this one and this one are adjacent, am I right? This one and this one is adjacent. This one and this one is adjacent. If I say adjacent, maybe you are not understanding. When we can say that the two cells are adjacent, if they are only differ by one single bit only. If you see that this position, it is 0 0 0 0, and take this one 0 0 0 1, only one bit is changed, so they are adjacent. Is it clear? Now take, lot of people will confuse whether these two are adjacent or not. Let me check it. This one is 4 zeros and this one is 1 triple 0, whether they are differ by single bit or not. Yes, so I can say that these two are adjacent. Even these one and this one are adjacent. So instead of covering these two separately, I can combine all four and make it as a single group. Okay, now think another one. These, how many? 4 plus 4, 8 are covered. These two are not covered yet. Now if I cover this one and this one, I'm able to cover with only 2. Am I right? I have to make it more. Am I right? Is it possible or not? We have to see. 2 is okay, but can I make it to 4 or not? This one and this one, this one and this one are adjacent. Will you agree with me or not? Yes. Is it clear? If you want to verify, you can verify. They will be vary by one bit only. So how many groups we got? 3 groups we got. So now we will simplify it. First come to this group. Okay, these 4 are covered. Now take the columns and which is the common part. If you take this one 0 1 1 1 is there, which is common? This one is common, so which is B. Are you able to understand? Now come to the rows 0 1 1 1, which is common? 1 is common, which is D. Are you able to understand? Then next one is this group you take, this total 4. Are you able to understand? So this 4, take the common part. What is there in the column? B complement is there common, and here you have the C complement is common, because this is the 0 0 0 1. Are you able to follow it or not? I request you to parallelly write in your notes also. Okay, and now come to this one. These 4 are covered. This one, this one, this one and this one. So take the first column, which is common. B complement is the common part. Okay, take the row which is common. D complement is the common. Are you able to understand? So this is the minimal expression we got. Then lot of people will get a doubt. Sir, you cover these 4 and next these 4. Why can't you cover this one? Again, make it another term. Why should we do it or not? We should not do it. Why we should not do it? Because these two ones are covered with the help of this group. Will you agree with me or not? That's why we got this term. And these two ones are already covered with this group. That's why we got the B complement and C complement term. Already if they are covered, we will not cover with a new implicant. Is it clear? If we cover, then we will get extra term. Then I can say that it is not minimum. Are you able to understand it or not? Now if you see that how many terms we got? 3 terms we got. How many literals we got? Okay, we got totally 6 literals. Is it possible or not? Yes, it is possible and we have proved it. So totally how many terms we have initially? 10 terms is there, and each term has the 4 literals. Totally we have 40 literals are there, and we have reduced to 6 literals. Is it clear? I hope you have understood how I simplified. See, using the K-map, we have simplified it in a very easy way. So that's why I said that initially also I said that using K-maps, you can simplify a Boolean expression in easy way as compared to the Boolean algebraic simplification. Using the Boolean algebra properties also we can simplify, but if you simplify using those properties, it will take lot of time and so many steps we have to do. But using K-map, we have done in a simple way. I hope you have understood how I simplify the given Boolean expression. If you still have any doubts, feel free to ask me in the comment section. I will try to clear your doubts in less than 24 hours. Thank you for watching my video. Have a nice day.